In this lesson, we're going to be talking about surface area of pyramids and cones. To find the surface area of a pyramid or a cone requires formulae and skills we have studied in previous lessons. However, there are some new terms that we need to look into, so this is where it changes quite considerably. Those terms are the apex, slant height, and perpendicular height. And these can be seen on the images on the right. So we're going to talk about that just briefly. So if you're looking at the pyramid, the apex is where all the, in this case, they're triangles going to this point. That's the apex. Now the slant height is, we just say height, but we have to talk about slant height and perpendicular. So perpendicular height is straight up to the apex from the base of the pyramid, where the slant height is straight up from the base of a triangle, so one of the sides, and goes up to the apex. So hopefully you can see the difference there. For a cone, it's the same. So the apex is the point of the cone. The perpendicular height is going straight from the middle up to the apex, and the slant height is going from any of this circle here, any part of this circle, going up to the apex. So when we're talking about the surface area of a square pyramid, a square pyramid has a square base and 4 triangular faces with equal area. So for this diagram, we've got S as the side length of the base, and I've got this cursive L, which is the slant height of the triangular face. So the formula that we use is for the surface area is side squared, which is for the square, plus 4 lots of the triangle. So it's normally half times base times height. But in this case, the base is S and the height of that triangle is L. So instead of having base times height, we have side times the slant height, which is what that L represents. So that's the new thing there. So we're just modifying a formula we're used to, and we have to kind of put it together with other things. So now we're going to use that formula and apply it to an example. A square pyramid has a base with side length 6 centimeters and a slant height of 4 centimeters. We need to find the surface area of this square pyramid. So if you look over here, there's the diagram, and we're going to first write the formula that we just mentioned in the previous slide. So I've also drawn a picture here to help us visualize what we're actually doing. So you can always do that. Remember, a net is certainly a viable option. And we'll see that the surface area is the side squared plus 4 times a half times side times slant height, which, remember, it's basically the same as base times height. We've just changed the letters. So we'll substitute those values in. So wherever there's an S, it becomes a 6. Whenever there's an L, it becomes a 4. And then we just take that formula with all the input values and put in the calculator, and we'll get a result of 84 square centimeters. Now we're going to transfer back over to the cone. So looking at this diagram, a cone has a flat circular base and a curved surface. So here we've got R, which is the radius of the circular base. We've got L, which is the slant height of the curved surface, and H, which is the perpendicular height of the cone. And the formula that we use is the surface area is pi r squared, because that's the circle. And then to get the area of this curved surface, it's pi times r times the slant height. Okay, so we're not actually using the height in this formula. Now we're going to apply that to an example. So for this example, there's 2 parts. The first part, a cone has a radius of 6 centimeters and a perpendicular height of 14.4 centimeters, which you can see in this diagram. And A asks, find the slant height of the cone. Answer correct to 1 decimal place. So, like I said, we don't need the H in order to find the surface area of a cone. But if you don't have the slant height, you need the H. So you can see here, we've got a right angle triangle. The base is 6 and the height is 14.4 centimeters. So we're going to have to use Pythagoras' theorem. So I've drawn the triangle of this part here, and I've labelled L for the hypotenuse. So normally we would have a squared plus b squared equals c squared, but because we've got some things that are a bit different, I'm going to be saying in different order, L squared, which is the hypotenuse, is equal to the height squared times the radius squared. So we know the height is 14.4, and we know the radius, which is 6. So I'm going to substitute those values in, and you can see that's what I end up with. Now, I want to get rid of that squared because we need the slant height, not the slant height squared. So I square root everything, and then I just type this straight into the calculator. We get our answer, it's approximately 15.6 centimeters to correct to 1 decimal place. If you want to, you can put in another step here where you show that you know more than just the first decimal place in your answer. Now for part B, we need to find the surface area of the cone. We need to answer to the nearest square centimeter. So now that we know the slant height, we can use this formula. So the surface area is pi r squared plus pi r L, in which the L stands for slant height. So the r is for the radius, which is 6, and the slant height we worked out to 1 decimal place is 15.6. So now if I just type that straight into the calculator, I'm going to get 407.1504, and it goes on, and that approximates to 407 centimeters squared. And that brings us to the end of this lesson, and next lesson we're going to start volume.